Okay. Okay, this one I just revised what we learned, so very short, very shortly. And then after that, you can ask me some question about anything. Okay. So firstly, we know that we learned about the hashing, right? So they are just a typical space and trade-off algorithm. So we can achieve the search time in O1. But of course, it's a trade-off, right? So we need some memory. So memory usage will be increases. Okay. So for the hashing, you know that each key we have the key we map into the hash value. Okay. Then we use the hash function for mapping. So the hash function will map the key into the value from 0 to h minus 1, where the h is the size of the hash table. Okay. So we have the array. You remember we have the array, right? We have the called a hash table with the size h, and each entry we call a hash slot. Okay. And then when the multiple keys are mapped into the same hash value, then we know that the collision occur, right? Because the key, when we have the key, we apply the hash function. Then if we have so many keys, and somehow it will be collision, okay? And we also have the log factors. It's just the number of the key divided by the hash table, okay? For the collision resolutions, we have two ways. The first way, we use the close addressing hashing. So for the close addressing hashing, we don't store the key into the hash table. We just maintain a linked list, right? So if they the collision, then we just create a linked list, then to keep track on the keys that have the same hash value. Okay. And we also have another way to resolve the collision. That is called the open addressing hashing. That's it. We store the key direct inside the hash table, and one slot, right? One hash table slot have only one key. So therefore, if there is two keys with the same hash value, then we need to do some way to resolve it. So for example, we can do the linear probing. Linear probing is just like looking at the next slot, right? If there's a collision, we look at the next slot until we find the empty one, then we put the key into. Or we have some like quadratic probing or double probing. Okay. So that's it about the hashing. Then we study about the graph. You remember the graph, right? We have the graph. We have the list of the vertices and the list of the edges. Okay. The V is the vertex, and edge is just connect the vertices, right? Two vertices will be connected by an edge. Okay. And the degree of the vertex is just a number of the edge incident to it. Then we know about the connected graph, right? Connected graph, if this in the undirected graph, the content means that for any vertex to any other vertex, there should be a path, okay? Not a direct edge, but as long as there is a path, okay? It can be go through multiple edges, but as long as there is a route, then this should be okay. Then we also have the strongly connected one. Okay, the strongly connected is for the directed graph. So the directed graph can be strongly connected if there's a path from any vertex to any other vertex. Okay. There are difference between the undirected graph and the directed graph. Because the undirected graph, right, we don't have the direction. So as long as A connect to B, then A can come to B and B can come to A. But for the directed graph, it's just one way, right? A go to B, but it's not guaranteed that B can go to A. Okay. And the graph we also call the cyclic if it contains one circle. Okay, one or more cycles. Otherwise, it called a cyclic. That means no cycle into a route. Okay. And we also have another we call a complete graph. Complete graph is just like every edge, every vertex will be connected to all the other vertexes. So they are called a completed graph. Okay. So for example, we have the completed graph here. So A connect to BCD, B connect to ACD, yeah, something like that. Okay. So then we have two ways to present the graph, right? Because this one, I mean, given this graph, we cannot we cannot put this kind of the structure into the computer. So we need to have a way to present it into the computer. So we have two ways. We call it adjacency matrix. Adjacency matrix is just like a matrix, right? V times V. Then if their connection, for example, 1 to 2, right? Then 1 to 2, we just put 1, okay? Otherwise, we put 0. For example, 1 to 5. 1 here, 5 here. There is no edge, right? So we put 0. So it's just simply like that, 1 and 0. 1 means that there is the edge connected to vertices. 0 means that there is no edge, okay? And we also can write in the adjacency list. Adjacency list is more straightforward, right? For example, 1 connect to 2, 3, 4, and 11, right? So we just create the linked list 2, 3, 4, 11 to keep it, okay? So that's the called adjacency list, okay? Then to travel a graph, right? We have the problem of the traversal, okay? The traversal means that we track on the node one and only one, okay? It means that we travel the graph, then we visit each node one and only one time, okay? So to traverse a graph, we can apply the breadth search and the depth search. You may remember, right? Breadth search is just when we visit a node, right? Then we visit all the neighbors of this node. For example, 11 connect to 1 and 2. Then in the next step, we visit 1 and 2 first. And then we continue 1 and 2, then we visit all the neighbors before we go depth. So breadth search is more about go wide rather than go depth, okay? For example, 1, 2, you connect 3, 4, 5, 6, blah, blah, something, until you visit the last one. So for the breadth search, to keep track this, we maintain a queue, okay? So repeat here. So we have the data structure, we have the queue to know which one we will visit next, okay? For the breadth search, different, opposite, right? Instead of go depth, instead of go wide, it go depth first. It means that we go as deep as possible until we cannot go, then we backtrack, we go to other path, okay? For example, we go 7, cannot, then go back to 3, 3 go to 8, and go to 12. And if cannot, then go back to other node 2, okay, something like that, okay? So we go depth until we meet the leaf node, then we backtrack, okay? So they call it a depth search, okay? Then we study about the backtracking, right? Backtracking is a way to try the various sequences of the decision until we find the one that work, okay? So you remember, right? For example, we have the start at every time we had a multiple choice. We don't have which choice we will choose. Then we just pick one, we go. Then we have another choice. Then we just pick one to go. To go until with that end. That end means that it is unsuccessful and cannot go further. Then we just backtrack to the previous stage. And then you choose another choice. So it's like the depth search, right? Then we just try, and cannot, then go back, okay? Then they call it backtrack, okay? We try until the end, we backtrack until we found the solution, okay? Then finding the solution, you have two ways. Either you can stop or you can just continue to search on the solution, okay? So they call it backtracking. Okay, backtracking is just try and backtrack, okay? Try if not success, then backtrack until we success, okay? And we also learn another technique we call dynamic programming, right? Dynamic programming is just the combination of the recursion and memoization, okay? For the recursion, we know that, for example, we just do the recursion, right? But there are many, duplication or repetition, right? Then we don't want to recalculate the one that we already calculate. So that's why we propose a dynamic programming. Dynamic programming is exactly the recursion, but we have one mechanism we call it memoization. Okay, memoization is just a memory, right? We remember in the lecture we have some array, 1D array, 2D array. Okay, so that we just memorize the previous result we already calculate. Okay, so for the dynamic programming, we can solve the problem that can solve using the recursively, but we had a memoization. So we just store the optimal solution to the subproblem into the table, or we call it memory or the cache, right? And normally in our lecture, we use the array, okay, 1D or 2D, whatever array to store the to store the solution we found, okay, the subproblem, the solution of the subproblem we found, so that later when we see it again, then we just check in the memory whether we have it or not. If we already have it, then we just reuse. If we don't have, we calculate it, but then after calculating the subproblem, we store it into the memory. Okay, so that is very simple like that. Yeah, that's the dynamic programming. Then we also learn about the matching, but because the matching is not in the, in the quiz or in the lab test, so I don't revise here. Okay, if you have time, you just have a look at this. So I think that's on about part 2 of the courses. Okay, so hopefully that after this one you have some understanding about the algorithm. Okay, because this one in this courses, right, we just want you to know about the basic knowledge, okay, the background, the basic knowledge about the data structure and algorithm. Then in the later course, in the later years, for example, in the year 2, right, you will learn deeper. For example, the course algorithm design and analysis. Then you learn deeper how to design algorithm, how to calculate the complexity, blah blah something. This course is more about teach you about the basic knowledge about the data structure and algorithm. Okay. Okay, I think that's it for the lecture. On the lecture we already learned. So for the final is for the lab test and also the final quiz, right? We only test you about what we teach in the lecture, in the courses. So you only need to reread the lecture carefully, then you can answer the question easily. Okay. Even for the lab test, right? I also won't challenge you much. Okay. So no worry. You just make sure that you understand on the lab, on the tutorial, and on the lecture slides. Then you can do it. Yeah. I will make sure that you can do it. I won't test you the thing that outside what I teach. Okay. So yeah, you don't need to practice in the lead code or HackerRank or whatever, because the question there usually harder than the one in the courses. Because in the lab test you only have 2 hours, right? Both for the quiz and the quiz and the programming questions. So I won't challenge you very hard. Okay. Memorization, yeah, to store on the subproblem, optimal solution of the subproblem. Okay, so you read the slides carefully, and then yeah, I understand that you are asking something about the question in the assignment 788, but yeah, you reread the slide carefully. Yeah, the answer are there. Yeah. Okay. I won't ask you something that I didn't teach. Okay, so you read the slide carefully. For the dynamic programming, you read the slide whether you can find on the solution or not. I cannot tell now. Okay. Okay. So yeah, again, even though for the lab test or for the lab test or for the quiz, it's on inside the slides. Okay, on the knowledge will be inside the slide. Okay, so that's why for some question in the assignment 5 and assignment 6, right? Some of you ask me why it's so difficult. I don't think it's quite difficult. So actually, I can go through this one so that you know how to answer this. For example, many students ask me about the question about checking. I mean, for the programming in the assignment. Let me find 5 or 6. Okay. For the assignment 6, there one question that asks you to check whether a directed graph is strongly connected or not, right? A directed graph is strongly connected or not, okay? So then you just know, okay, what is the strongly connected graph? Strongly connected graph means that given any pair of the vertices, right? Then there must be a path, okay, from for example pair A to B. Then there must be a path from A to B and B to A for any pairs like that. Okay. Yeah. So that's the principle. Okay. Then you know that for the breakfast search or the depth search, you can use it to find on the node that can be reachable from particular node, right? They are starting node, right? For example, node A, if you apply the breakfast search or the depth search in the node A, then you can find on the node that connected can be reachable from node A, correct? That's the result, the visiting array. After you apply the breakfast search on the node A, then you can find all the nodes that can be visited by A, correct? So for the directed graph, so the question is how to check this is the strongly connected component. It means that given two pair A and B, how can you know that A can be reached by B and B can be reached by A, right? Can be reachable by A and A can be reachable by B. I don't know. Maybe some of you may go to the Google and find that okay, this one you need to apply the what they call the reverse graph something, right? So you ask me why I don't use the representation. You can do the reverse graph or something. That's very complicated, right? Of course, you can use a reverse graph to solve this problem, but this one is not not tough in the courses, right? This is the optimal solution, but in this assignment, I don't ask you about the optimal solution. I just ask you to apply what I teach. So what I teach is you just need to make sure that, okay, given two pair A and B, A can be reachable from B and B can be reachable from A. Then what is the simple solution? So the simple solution is that for every node, right? Every node in the graph, right? You just apply the breakfast search or depth search in this node, and you check whether you can reach on the other node. Okay. This means that, for example, for node A, right? You apply the breakfast search, then you can know that whether A can be can reach on the other node. Okay. This means that you okay, then A can come to other node, and then you just do the for loop for on the node in the graph, right? This means that you just apply the for loop, and then for each loop, right, you just find the breakfast search for this node, okay, and then you can find the answer, right? So it means that you just apply the breakfast search, and then you apply the for loop outside, and then you can answer the question, right? You don't need to think so much about that. I mean, the strongly connected component means that every node can be connected to the other node. Then you just do the for loop for on the node, right? Yeah, of course, it's not the optimal solution, right? It's not an optimal solution, but yeah, I just asked you, I mean, a simple one, okay? For the Friday, I mentioned there no lecture on Friday because they are public holiday, okay? So if you have any question, you just email to ask me, okay? So the complexity for the solution, of course, is not the optimal one because do the for loop, then they are V, right? V time with the breakfast search complexity, okay? Well, of course, it's not the optimal solution, but I don't ask you about the optimal solution. Optimal solution using the, I mean, the reverse graph, but they are very complicated technology, right? Okay. Okay. Optimal solution, like I mentioned, you do the reverse graph. If you have something, you can read the Google things. They have the solution for that. Okay. For the test, right? For the test is not on Friday, right? I think the test is on 21. 21. This is the Thursday. Yeah, this is Thursday. Okay, Thursday, not Friday. Okay. So make sure that you don't miss the test. Okay. So the test is next Thursday. Okay. So for the time, okay, I will send you the time. But I mean, if you are in the morning session of the test one, then you will be in the yeah, it will be just like the first half. Okay. I mean the morning or the afternoon session. I check the availability of the lab, but normally, I mean, yeah, if you are in the morning session in the lab test one, then you will be in the morning session of the lab test two. Okay. Okay. Wait, one by one. Okay, for the techniques, right? For example, for the implementation of the breakfast search or the breakfast search, if I ask you, right, if you apply this, then of course I won't challenge you much. So I will give you the pseudocode for breakfast search or breakfast search if I ask you. Okay, so you don't need to remember how to implement the breakfast search or breakfast search, because this one I just want to test you whether you can understand about that and you can apply that. So if I ask you something applying the breakfast search or breakfast search, for example, finding the connected not or not, right, then I will provide you the pseudocode for this also. Okay, so you don't need to remember the breakfast or breakfast implementation. Okay, so I give you the pseudocode. Then from this pseudocode, you can easily implement, right? Okay. ESAFE function also provided. Okay, so like I mentioned, ESAFE function, for example, if I ask you something about the, I mean, the backtracking something, the ESAFE function also provided. You only need to implement the main things, that is the backtracking things. Okay. I mean, if I provide the pseudocode, then you can easily put it into the, I mean, the question, right? I also provide you something like the queue, the stack, blah, blah, something. I provide you on the, I mean, the data structure things. Okay. You only implement the main function. Okay. I will provide you the queue, the things. Okay. Yes. And okay. And this is very important. The template I provide, right? You can free to modify the template. You can add anything, any your own function, anything, as long as you did not change the output format. Because for the test case, right, what I evaluate is the output format should be exactly the same. Okay, so you don't change the output format, but you are free to change the whole template. Okay, if you don't like my provided function, you can use your provided function. Okay, understand? But don't change the, I mean, uh, don't change the template. Okay. I mean, if I ask you the methods, then you should do that method, right? If, for example, I ask you to apply the dynamic programming, then you should apply the dynamic programming. I mean, you should not apply, you should not just use the recursive function. For example, if I ask you Fibonacci, I ask you implement the dynamic programming for Fibonacci, right? Then you should, implement the Fibonacci algorithm. Because if you just apply just a recursive function, simple recursive things, right? Then you cannot pass the test case for sure. Okay. But you are free to modify the template. You can add more function, blah blah something. It means that you don't only need to write in the portion. Write your code here. You can free to modify the template also. Okay. Yeah, if you can. Okay, if you don't know, then you can use a proof of search. But I will, design the test case so that you cannot find a solution. If you use the proof of search. Okay, for the top down and the bottom up, I will let you choose, free to choose. Okay, so normally in the question, I don't force you to use a traversal or a traversal. I will just ask you to use a dynamic programming. Okay, so you can use a bottom up or the top down. It's up to you. Okay. It's also easier for me to mark, right? Because I'm not so sure, because I just run the test case. If I know that I need to know whether you use breakfast, top down thing, I need to look at the code. But normally for the dynamic programming, I let you free to choose top down or bottom up. Okay. I won't force you to use top down or bottom up. Okay. For the breakfast or default, I will also provide the pseudocode for that. For the breakfast and default, and also on the utility data structure like the queue or the stack or something, I will provide to you. For the backtracking, I also provide you the eSave function. Okay, you just call it eSave or something. Okay, they are on the utility function I will provide to you. But of course, you can free to modify the whole template, but don't make change the output format, right? You make sure that what the output format should be exactly the same like in the template. If you modify it, then what you output maybe not match with the one that I tested in the test case. Then you will fail the test case. Yeah. Okay. So like I mentioned, right, for example, so you like using the file flat or something in the lab 7 question 3. It's just a sample solution. You can free to use anything, okay? So I don't force you to do exactly in the lecture, okay? So you're free to do as long as you can find the answers, and then you use the same technique I mentioned, okay? Like you use the dynamic roaming, you use a breakfast search, or you use a depth search, then okay. Yes. Okay. Normally you can answer the question without additional function. Okay. If you use my my template, then you don't need to implement any additional function, but except the dynamic programming, right? Dynamic programming, you need to implement the memory yourself. Okay. So you can put the memory as the global variable. You can put it in the main function or whatever. Okay. Or you can put it like the things are okay. For the doctor log, I didn't see the question. Okay. What do you mean by matrix? What do you mean by matrix? Can be more details? What do you mean by matrix? I'm not so sure what you mean. Memory is just array, right? 1D array or 2D array, or it depends on the question, right? Okay. But I mean the memory you need to implement. I don't implement for you, right? Okay. It's just like the assignment 7A8. you need to element the memory. Okay. Memory is just the array 1D, 2D, or whatever. Yeah. Okay. But we need the memory. Okay. So this one, you can put it in the main function, or you define a global variable or whatever. It's okay. Okay. Even though for the template function, right, you can also modify the arguments. Okay. It's up to you. Okay. So free to do, as long as you don't modify the output format. Okay. So any more question? Yeah, this one is just the open question and answering. Okay. For the snapshot, you do not need. What do you mean the variable for the array? Okay, for the snapshot, right? For the snapshot, you also need to define the memory, right? If you use a dynamic programming, okay. Dynamic programming, you have to define the memory for sure, okay. For the backtracking and dynamic programming, which one is better? Of course, I mentioned dynamic programming always better. Dynamic programming normally is much better, okay. You can see, right, for example, if you just use the backtracking for some solution, for example, the Fibonacci, the complexity is 2 power n, but use a dynamic programming only n, right? And in the lab, 7 and or 8, I remember, Fibonacci one, right? I also tell you to run the Fibonacci with a recursive function and a dynamic programming, and maybe you just run the Fibonacci 40 or 50, you can see the difference. For example, you run the Fibonacci for 40, right? For the recursive, it takes you like 1 minute, 2 minutes. For the dynamic programming, it's less than 0.1 second. Okay. Okay. Backtracking or dynamic roaming in the exam, in the lab test, I also ask you. For example, implement the dynamic roaming, then you should implement the dynamic roaming. Okay. If I just ask you implement the backtracking algorithm, then you just need to implement the backtracking algorithm. Okay. For the assignment MCQ, we can ignore the problem size. What do you mean? Mean we're unable to know how many other possible solutions exist. Assignment question 3. Yes. Assignment question 3. You mean the programming one, right? Or the MCQ? I forgot what the question. Let me double check. Question 3 mean that question 3 of the programming, right? Let me double check the question. MCQ one. Okay. MCQ, what is MCQ? Okay. So cannot find all the solutions. It means that, for example, if there are many solutions, right? For example, for the n queens one, right? For example, you can have many solutions, right? Then which one cannot find all the solutions? Yeah, the question is like that. Yeah, you can ignore the problem size or something. Yeah. Okay. So given, for example, for the n queen, okay, 8 times 8, okay, we have, like, I remember 92 solutions, right? Then which one cannot find all the solutions? Okay, the question is like that. Okay. I don't provide, I don't give the tricky question or something. You just think simple like that. Like and queen problem, they have the 92 solutions. Yeah. And which one you cannot use to find all the solutions. Okay. So any more question? I remember one student asked me about the makeup exam. I suggest that you should join the lab test. The makeup only reserved for like the COVID-19 case or something like medical cases that you cannot join the test. The lab test. Okay, on the day of the lab test, so I have to make the makeup one. But don't try to make advantage for the makeup because the makeup it's not easy. I mean it. I mean on the morning or the afternoon session or even though the makeup session, right? The question will be totally different. Okay. So the makeup session as long only in the case that you have some medical problem or something that you cannot join the lab test. And then you can take the makeup. Okay. But I suggest that you should join the first one. Okay. I mean the lab test, not the makeup one. Makeup one is just in case we cannot in some medical condition or something. For the snapshot algorithm, right? This one is just about the choosing, right? You have a few for the snapshot. It's just about you have a few resources, okay? But you don't have you have the limitation of the size or something. Then you need to maximize the things. So that's more about the resources, but with the capability capacity. Okay. Oh, last Friday. Okay, yeah, I will upload the last Friday. I think I forgot it. But last Friday is about the matching, right? It not will be tested, but I will upload right after this one. Okay. I will also upload this lecture into the YouTube. Okay. So again, there is no lecture on Friday, okay, because of public holiday. So from now until the lab test, if you have any question, you just email me. So we try to answer all of this. So again, right, for the lab test or the quiz, you only need to look at the slide, understand about the lab question, the assignment. Then you can do the lab test and the quiz. No need to go to the lead code or hacker rank to practice. I won't challenge you very hard question like that. Okay. For the doctoral question, I don't have the controller. But anyway, it's just 5 questions in the final quiz, right? Okay. So for the quiz, will be 5 questions from the part 1 and 5 questions from the part 2. Okay. But I believe the MCQ should be easy. Easier. Okay. Okay. If you have any question, you can ask me here. Otherwise, yeah, you can leave. So see you next week. Yeah. See you on the lab test. I will be there also. Yes. 10 MCQ question and 3 coding question in 2 hours. Okay, see you. Yeah, see you guys. Okay, bye.